Hi, my name is Thenuwara, and my partner Jimmy Chu are from San Jose State University's Department of Biomedical, Chemical, and Materials Engineering. And on behalf of my team, I'll be presenting about the application of quantum dots in biodetection. Here's a quick overview of the presentation. I will be briefly talking about what quantum dot and biodetection is and how they tie in together. I will conclude with why we want to be using quantum dots over some of the traditional matters that were used in the past. Again, the information presented will focus on how and why quantum dots are used in biodetection. So what is quantum dots? It is basically nanoparticles of semiconductor material to replace traditional organic dyes that were used in biodetection. Quantum dots display fluorescent properties which allow optical detection of presence of certain biochemicals. This happens through the excitation of quantum dots using UV light and other material interactions. Quantum dots can be broken down into two parts: the fluorescent core and coating or shell for chemical and fluorescent stability. So moving on to biodetection, is an application of microfluidic technology for biomedical purposes. This technology allows simultaneous study of large number of cells, virus, and other biochemicals that are dispensed in the onto the detector. So how it works? Basically, to start with, there is a microbead array for biodetection, and in this for this microbead array to function as a biodetector, there has to be a few things done. First, the microbeads needs to be implemented and trapped into wells where a reagent will pass through. And the microbeads are composed of quantum dots bonded onto strands of antibodies, DNA, or other matter that allow interactions with virus and cancer cells that we want to detect through biodetection. Reagents are dispensed through the inlet and made to pass through the channel with quantum dots, and the quantum dots act as labelers binding to specific cells, for example the cancer cells or the virus, to allow detection of such target entities in the reagent. The top half of the diagram is a representation of the microbead array used with the quantum dots sort of sectioned into it, and these these wells are where the target entities will bind, and the reagents are dispensed through the inlet, and it flows through because of the outlet that exists at the end of the channel. And so how it works, it's just, when it's boiled down, it's just reagents are dispensed through microchannels and wells. The target entities binds with the quantum dots as it passes through the channel, and bound entities emit fluorescent light that allows visual detection of its presence in the sample. And finally, the advantages of quantum dots in biodetection. There is improved detection sensitivity when using quantum dots, and there is a resistance to photobleaching, so it can be left out longer in the ambient condition, which was impossible using traditional organic dyes. And there's lower pH sensitivity, which allow a wider range of samples to be tested, and it is simply brighter than the traditional dyes. Here's a quick reference of what we've used, and thank you for listening.